welcome once again to this module of handling large scale data using Stata. So far we have been trying to understand, and we wish to go into the deeper understanding of quantitative analysis of qualitative data. In last 3 lectures we have been explaining the qualitative variables, qualitative dependent variables, and LPM and Logit has already been discussed. But now onwards we are going to discuss, in this particular lecture we are discussing on Probit and Tobit model. Probit, where we wanted to understand whether the error distribution or the distribution function follows a normality or not. In Tobit, there somewhere we are going to discuss whether there is a censoring of that particular data. Okay. Now, and again we will also compare all those 3 models together, whether LPM, Logit and Probit, which one is actually better, okay, why it is better. So, now coming to the understanding of Probit regression. I will take a quick wrap up of the understanding, since many aspects of Logit and the distribution function has already been explained. So, the Probit is actually a variant of Logit, okay, modeling based on different data assumptions. These 2 analyses, that is Logit and Probit, are actually very similar to one another, but the Logit uses a cumulative distribution function, but whereas the Probit uses a normal density function, cumulative density function. Okay. Now coming to the estimates of the Probit, since it follows a normal density function, we wanted to mention that Probit model is also called as a normit model. Okay. Now this was initially coined by Chester Bliss in 1934. Then that stands, the term Probit actually stands for a probability unit, okay, and a fast method of computing maximum likelihood estimates for them was proposed by okay. So, basically the first the maximum likelihood estimates were initially proposed by Ronald Fisher in an appendix to Bliss of 1935. Okay. So, the name is from probability plus unit, that is why it is called Probit, okay, probability unit. In short, it is called probability unit. The purpose of this model is to estimate the probability value. The parameter of interest in Probit model can be estimated through maximum likelihood method also. Probit is significantly more sensitive to outliers than that of Logit, because Logit, the outliers have the distribution of the probability change in the outlier is very less in case of logistic distribution, whereas the probability change in case of the outlier in case of Probit distribution is very sharp. Okay. Now, the Probit model is used to model dichotomous and binary outcome variables. In the Probit model, the inverse standard normal distribution of the probability is modeled as a linear combination of the predictors. Okay. So, inverse of the standard normal can be modeled in terms of linear combination. Okay. Now, Probit regression model, especially for the response variable y binary, can take only 2 possible outcomes, that is 1 and 0. Here y represents 1 or represents or presents 1 as presence, okay, and absence with 0 of certain condition, such as like in our example, maybe a person in labor force to be coded as 1 and not in the labor force to be 0. Okay, and y is influenced by the set of regressors, that is x. Okay. We assume now the model takes the form like y with a probability of success given the x is nothing but the the probability density function or the probability function, cumulative function of x beta, okay, where p denotes probability and f denotes the cumulative distribution function of the standard normal distribution. Parameter betas are typically estimated by maximum likelihood method. Here we also wanted to mention that it is possible to motivate the Probit model as a latent variable model, because since probabilities of the variables are estimated, the probabilities and its expected values could be defined as not the exact value, rather the representative values called latent variable model. Suppose there exists a latent variable or auxiliary random variable, then Probit can be also most fitted. Then the model looks like this. Y star is actually the unobserved variables with the error distribution of epsilon with 0 and sigma square is standard is variance. Then y is viewed as an indicator of whether this is latent variable is positive if y is equal to 1, okay. And if that is y star greater than 0 okay, or that is nothing but this is greater than 0, that is if and only if that is the case, then the error will be greater than that of the negative value of its the estimated values. 0 otherwise, if it is 0, then in that case the error value will be in that case the probability of error values can be estimated till that of the xb limit, okay. So now basically in the density function, if you or the probability distribution function, if you can estimate till that particular time is more important. In once based on this equation, if you simply divide the standard deviation in both the side, the probability limit is actually defined here. If any specific value till that value if you are calculating and their probabilities you are estimating. Now the probability limit of this error is estimated through this, okay. We are going to mention. So now in the total density function, cumulative density function, since the entire probability is 1, so 1 minus till this is nothing but 1 minus till that is nothing but the cumulative probabilities of x beta upon sigma, and if that is these two are equal, that means the distribution is perfectly symmetric, okay. If both the sides are equal, this side as well as this side, if is basically probability of success in one side as compared to another side, if they are equal, that means the distribution is bell shaped and symmetric, okay. So probability of success given the explanatory variables is nothing but the function, the density function or the cumulative distribution function denominator with f is nothing but x beta upon sigma. So that is basically beta naught plus beta 1 x, okay, we are referring here, divided by sigma. So now this is nothing but f is nothing but standard normal cumulative density function, okay, for the level of error values. We cannot estimate both beta and sigma since they enter the equation as a ratio, okay. So here they are coming as a ratio here, it is not individually separated, alright. So we set sigma is equal to 1, making the distribution on epsilon or the error a standard normal density function, okay, when this is 1. So basically we are referring to a standard normal density function. So if the probability value with the success of occurrence in the dependent variable is 1, probability of success is 1, that means we end up with this estimation. So we are basically estimating till that level this estimated value from with the z value of minus infinity to infinity, probability value is from 0 to 1. So we are estimating on the diagram till this level, which is equivalent to our estimated value, okay, in the model. So now since it follows a normal density function, we are referring to a normal density function equation, okay. This is a normal density function, and since integration we are using, so the delta change in that distribution is also attached. So, 1 upon square root of 2 pi e to the power minus usually it is to be z square upon half of z square upon 2, but here t distribution is considered because of the limiting in the sample. So, so the density function equation is clearly given for the estimation, where t is the standard normal variable with its distribution follows 0 and sigma square. Now, we can obtain information on probability that is of occurrence 1, that is the inverse of the probability is nothing but the linear function of it that can be estimated. The inverse of the probabilities will give a linear equation, and the interpretation whatever the probability value you get it, if you take a inverse value of it is basically that is called beta 1 or beta naught. Okay. The inverse transformation is called the Probit. Okay. The inverse transformation is actually called the Probit value. P basically the P value is nothing but the inverse transformation, which gives the linear predictor of a function of the probability. Now, let us compare Logit, Probit and in LPM together. So, now let us first two are compare. Logit model or Probit model are both are not linear. Okay. So, which makes things difficult. To make the model linear, we make some forms of transformation. So, log transformation or inverse transformation in either of the case of the on the dependent variable is actually going to make it linear. Okay. So, both methods use maximum likelihood estimator, this is one. So, linearity aspect I have discussed. Now, transformation is important. So, we require more cases than a similar OLS model. So, in order to make it likelihood estimator, it usually go by iteration. Iteration require more number of cases. Okay. Cases OLS now less number of cases can derive a better result, but both the models require more number of cases. That is another important aspect to be mentioned. Logit models we do not unlike Logit models we do not get odds ratio with Probit models. So, Probit never gives odds ratio. Okay. It gives the probability value. Probit regression is an alternative log linear approach to handling categorical dependent variables. Now, question always come which one to be taken. Now, we are mentioning very clearly okay, that there is no such major difference except the distribution function. Logit and Probit models generally give similar result. Okay. Now, the main difference between the two models is that the logistic distribution has slightly fatter tails. Okay. So, Logit has a fatter tails and the tails are more fatter, whereas in case of Probit the tails are very sharp, and when it approaches to 0 or 1 the end is very at a very slower rate. The conditional probability P approaches 0 or 1 at a very slower rate in Logit than that of Probit. Since the tails are flatter, approaching very fatter at the end, okay, the slope is very less. So, that is the reason why the change at the end nearby 0 and 1 in case of Logit it is very slow, whereas in case of Probit there is a sharp change. Okay. In practice there is no compelling reason to choose over the other, okay, that is important, and do not get confused. In practice there is no such hard and fast rule to go by any single model. Many researchers choose the Logit over Probit because of its comparative mathematical simplicity. Okay. Mathematical simplicity, Logit is preferred. Another difference is when the error term follows logistic distribution, Logit model is appropriate, whereas if the distribution is of standard normal function, Probit is most appropriate. Okay. Now, marginal effect of the Probit model and Logit we have already discussed by taking first order derivative. Similarly, in this case also p values is expressed with this. Now, we are taking dp by dx. Now, beta 1 will separated due to dx, and f prime or f, you can write down f prime or f, it is up to you how you are writing, okay, to indicate the first order derivative. Now, the effect of change in x on p depends on the value of x. In practice, we usually evaluate the marginal effect at the same average or at the sample average of x bar, okay, that is marginal effect conditioned upon the sample mean, okay, of each of the variable. Now, when x is binary, it is not clear what does the sample average mean. Okay. When the x is binary, it is very difficult to interpret. Okay. So, the marginal effect then measures the probability difference between 0, 1 and 0. So, that is basically probability of 1 given x equal to 1 or minus probability of 1 when it is 0. Okay. So, 0 and 1, if you compare the probability of difference, that is basically called the marginal effect. The marginal value we are going to get in this case is nothing but if it is categorical, it is not the average that matters, rather the probability of occurrence in both the case. Okay. When we subtract it, that is basically our marginal effect. Okay. Now, some caution we need to follow while comparing models, especially Logit or Probit or even LPM. Though the Logit model, though the models like these three do the same thing, estimating probabilities, one has to be very careful in interpreting the coefficients estimated. The coefficients are not directly comparable. Okay. So, there is no standard technique is followed just to compare, but some rough approximations values are there to compare. But there are certain ways to compare the models, as I just said, by multiplying coefficients by certain value. Okay, like Logit, beta value of the Logit is 4 times of the LPM. Okay, whatever the coefficient LPM gives, if you multiply by 4, it gives the Logit value. So, similarly, 1/4 of LPM, 1/4 of Logit is nothing but the LPM. Okay. So, now regarding Probit and Logit, Logit value is more than that of the Probit value. Okay. So, that is 1.6 times of Probit value. Probit gives probability value, probabilities value Probit. But in this case it gives likelihood estimator, but in that case, in both the case more or less are the same, but the difference is of usually of 1.6 times. Okay. Similarly, if you just take divide 1 upon 1.6 times, it is 0.625. Okay. Now, another comparing Probit with LPM, Probit value is much higher, that is 2.5 times than that of the LPM. Okay. So, these are some comparable estimates made by different experts. We can also compare our coefficient by taking all the coefficient together. Okay. So, we have a practice data set, that is BCM practice we are going to provide you. We are going to check all 3 models together and running those commands for the same dependent variable, that is women being a necessity entrepreneur, with Probit regression approach at the first, then we will compare. Okay. Then we will discuss their coefficient estimation on their standard errors, then direction of the coefficient and the partial effects. Okay. We will discuss some of those things right now. All right. So, this is where we are going to operate. Now, it is here. So, we will apply the same data. Okay. Then we go to the estimation on the same data. We are simply deriving, we have derived the Probit result. Okay. So, Probit result is here. Now, first need to check this value, the chi-square value and its significance level. Okay. This is the first requirement. Then we can come to the interpretation, but it only gives the coefficient, but marginal effect is more important. Now, we have to go to the slide. Okay. So, coefficient are not that important. We have to find out the the partial effects, that is more important. Okay. Now, this is what the result we derived. Now, the model took 4 iteration at this moment, 4 iteration to converge. The log likelihood is of minus 2105, it is given here on the log likelihood on the very beginning. The log likelihood is used to compare some nested models if you have. The likelihood ratio that is chi-square test is of 2194 and highly significant, that I have already discussed. Okay. Now, this actually fits significantly better than a model with no predictor. This is what it is interpreted. Okay. Now, let us interpret the coefficient. The estimate of the coefficient in the Probit model cannot be interpreted as the change in the probability that y equal to 1 associated with a unit change in x. That is not going to be interpreted because of the categorical values. Okay. Now, we have to take the marginal values, and we can only check for the sign whether it is positively linked or negatively linked. I think coefficient has already been mentioned, positive negative in the coefficient table in the very first column. Then coming to in analyzing binary choice model, the parameter of interest are not the index coefficient, rather the marginal or the partial effects. Okay. The command for this task we have already dealt in Logit. Here we can also go by margin with the same command dy by dx asterisk. It means we will get the result like this. Okay. The result here is interpreted like the earlier way we interpreted. Here also the same way we will discuss, like for edge this is now 0.01 percent points. Okay. Edge square it is 0.003. Okay. Now, like similarly for urban and rural comparison, 2.57 times. For urban it is 2.7, 0.027 is there. So, in percentage it is 2.7 percentage points lower. Okay. Probability of being necessity entrepreneur. So, you can go through further details, and let us go further. The choice of Logit and Probit model is on the researcher, but there exists one difference between Logit and Probit model. That Logit model that is when the residual follows the logistic distribution, you apply Logit model. When the residual follows a standard normal distribution, we should apply Probit model. We run the Probit model and then predict the values of residuals. Okay. Now, we will go by the first we have already run the Probit regression. Now, we will predict it, predict the residual, then we will go by kernel density function. Okay. Kernel density of its normal function, then everything will be fine. So, now we will go by predict R, that is our now residuals have been predicted. Now, we will go by kernel density. Okay. So, the k density R a value predicted, the predicted values of R has already come. Okay. We are now giving k density of R. Okay. Now, normality test, we are going to give a normality test of it. It gives a diagram. Okay. It is now estimating or deriving. Now, still it is running. Now, look at the diagram, the graph of the predicted values, that is highlighted in blue color. Okay. The red one is the normal density function, the standard the standard normal density function. The estimated one is in blue or black color. Okay. Now, that is now look at very clearly. It seems the graph seems asymmetric. Okay. It is not symmetric, it is nowhere closing to the normal distribution. The normal density function is not overlapping with this or nowhere near to the normal density function. So, that is the reason why we are not accepting these distributions to be normal. So, in this case it is suggested that we should apply Logit model. Okay. Probit is not the best fit. Now, this is what we said already. Now, we are going to compare all the models together and to decide what is the best fit and how we should go for it. All right. So, we have three if you go by this command quietly regress with the LPM model. Okay, for the LPM model quietly regress, if you do it, what we do, we can quickly do that. Okay. Let me show you. We can quickly copy this command or run this command and show you. okay, how it works, all those okay. So, this basically Logit and LPM we are running together, okay. All right. So, so now both the results, now here you can see now the new estimated values has already been derived for LPM and for Logit. Okay. So, now we are going to show the Probit also, going to show the Probit as well. Now, we are also comparing all those three together. Okay. In this command we are going to compare as well. All right. Now, first command is for Probit. Now, you can see from this here line Logit BLPM is for LPM, okay. Then the second one is for Logit okay. Then third one is for Probit. So, now after that we have compare all these three together, okay. This is for LPM linear probability model, then Logit, then Probit. Now, from all those models we have got a comparison clearly. First column is for LPM, then second and third are Logit and Probit respectively. Each of the coefficient can be compared and how they differ each other. That some of them we have already discussed in the previous equation, that 4 times related, 2.6 times related, that you can compare and find out. All right. So, now this is what we have done. Now, here I just wanted to mention that the t value and other stats like number of observation and log likelihood specified very clearly. So, here first of all we specified with t and its log likelihood values, but now you can also specify with its significance level. Okay. If you specify significance level, the significance with star mark is also going to come. Okay. The star mark against the coefficient will be there. Now, once the star mark is there, you can compare whether which coefficient is, which variable is actually significant in which particular model, okay, and it will be easy for you to decide. All right. So, that is the reason why quietly command is used to suppress terminal output, okay, and these estimates stores basically gives the estimates result of different models together, okay, and in estimates table particularly store gives actually keep it in the model, and table gives in all those models together. All right. So, then basically in a single formatted table. Similarly, we can also compare marginal effects of these three models. Similarly, we can type quietly regress, okay, with quietly regress, that is basically the LPM model. Marginal effect is with the same regression model itself, whereas in case of I mean after the regression only, in case of LPM we have to quietly margin then dy by dx star, it means that will give you the marginal effect, but usually that is not necessary in case of continuous data, okay. And LPM, since it considers to be continuous series, though the dependent variable is binary, that is why we are running marginal effect. Then similar command estimates, store, margin, LPM, it will save, okay. Now, then we go for quietly Logit, then with all those commands for Probit as well, Probit, okay. After running Logit, then we discuss about the marginal, okay. Then we also store it, store will save it. Similarly, after Probit we will go for, in the next slide it is from its margin value it means, then we store it. After storing all those things, we can take all those three models together, okay. When you take three models together, we can able to decide whether which one is better. Likewise, we have just shown in three columns, okay. Here 3 columns, if you are confused, here only coefficients we have shown, okay, only coefficients shown, but in our next other slides we have already mentioned that if you run by their marginal effect, the marginal coefficient will be visible. All right. So, I am not running several times because of paucity of time, okay. So, with that we finished the discussion of LPM, Logit and Probit. and also we decided which one is most fitted based on their coefficient, their significance level, based on their distribution function, okay, and so on. Now coming to Tobit regression model, the last model in this series is on Tobit, which is also called which is also an extension of the Probit model, originally developed by James Tobin, as you might have heard, as Nobel laureate in 1958. Often the dependent variable is actually constrained. Many cases, it is censored. There is a limit. Like those who are estimating the some policy implementation of a particular like PDS scheme, for example, and that will be applicable for the below poverty line people with below poverty line. So all the income earners are not going to be considered. Somewhere you have to censor. Okay, so you have to define a benchmark level of income. To that only you are going to give. If you want to give more number of people in that caveat, then you can change that censored limit, okay, and accordingly we can run the regression. So usually it takes on a positive value for some observation and others 0. If you have censored, then censored values are considered to be 0, and these represents non-continuous data, as there is a large cluster of observation at 0. Okay. Such samples are also called censored samples. Basically those are considered to be 0 are called censored samples. Therefore, such models are also known as censored regression, or also called limited dependent variable models. Using OLS actually method leads to a biased estimates, because in any case this is categorized into 0 and 1. These are not a continuous series all totally. Though the non-censored variable or the values are of continuous, could be continuous, and different than that of the existing Logit and Probit model. So let us understand in terms of example. We said that the data set, we have already referred the data set of the enterprises context. The data set containing here containing information on the value added of any enterprise. In this case, some enterprises have positive value added, while others have 0 value added, or they report negative. Okay. So far as the value added of the enterprises is concerned, enterprises and their value added figures are available in the 7th round. Okay. Those who have reported negative value added are considered value added equal to 0. Okay. Because no question of negative value added is valid. Okay. You can say make it to 0. So thus in this case the enterprises are divided into 2 groups, say N1 or N2. So N1 whom we have information on the regressors, like type of enterprise, their location, age of the enterprise, as well as regression, that is value added we are discussing. So N2 is all about whom we have information only on the regressor, but not on the regressand, because it is of either 0 values or negative values, okay, or no information. So for OLS estimates of the parameters obtained from the subset of N1 will be biased as well as inconsistent. So there is another type of sample distinguished from the censored sample called truncated sample, in which information on the regressor is available only if the regressand is observed. Okay. So when the only regressand is observed, then in that case we get the truncated samples. Okay. So now in some mathematical interpretation, we can simply identify that the model is y of x I beta of epsilon, with epsilon, the error distribution is distributed with 0 and sigma square variance. So let us find the cumulative density function, cumulative distribution function of yi given xi, where we are limiting the y with certain level of yi given xi. So here a limit is given correctly, okay, less than or equal to, that is going to be valid in our case, or entire yi is not going to be defined, okay, in this particular distribution. The uppercase, that is uppercase of f, typically denotes CDF function or the cumulative distribution function. Y is stochastic variable, the above equation defines CDF that the probability of stochastic variable y is smaller than equal to that yi we are defining here. Okay. Here yi is sort of realization putting values of stochastic variable from linear model. Similarly, now after discussing this y we can further disaggregate to its beta coefficients and epsilon with the limit. Now error can be defined, error distribution is defined as this yi minus of this estimated coefficients. Now the distribution where we are going to estimate given xi can be defined with this probability value. Now this is the epsilon with respect to the standard deviation is a normal distributed variable. The probability that the standard normal is smaller or some number that is indicated with phi. The above equation can be written as phi and in terms of phi as a function of yi minus x beta divided by sigma, which we have defined just a minute back, that is the probability distribution function. Okay. Now by taking their derivative we get the marginal value, and the marginal value since sigma is there. So and these are constant. So and this is a small phi and indicate the marginal difference of the equation. Okay. This follows from here. And in Tobit regression basically we formulate a model where we think of a latent variable, say with that is yi. Okay. Latent variable on observed variable, since probabilistic issues are attached to that variable. So that is why we are mentioning is latent here. Okay. So yi star is censored above or below a certain value. So that is it is basically not observable for part of the population. Okay. And so part of the population, since not observable we can censor it, alright. Now in this example, like yi star is enterprise value added, and for a randomly drawn enterprises, the actual value of the wealth recorded up to some threshold, let it be 10 lakhs, but above that level only the fact that value added was more than 10 lakh is recorded. Okay. Similarly, negative values can also be censored. If above value and below value or negative value can also be censored. Okay. Whichever we require for the necessity of the model we can censor or accordingly. Based on this assumption we can split the probability density function as like this, like the way we defined here, okay, like this, alright. So there are different limits, like we can define if 1 for if it is less than certain limit, 2 for if it is with another bracket. Okay. We can categorize their probability limit. Now let us come to the example to estimate it correctly. How we can estimate it? But somewhere we have to understand that there are some limits defined. Out of the total data we can censor at the below, at the up, or at the medium. So you can give their coefficient accordingly. So from the 7th round of the data, we have a practice data set called Tobit practice data set. We are going to open right now. So our data contains 3,509 observations. Our objective here is to explore the factors which explain the performance of female entrepreneurs with a certain caveat. Okay. So our dependent variable here to be estimated with a censor value for its gross value added. Okay, of the enterprise. Gross value added measure is in rupees, that ranges from minus 20,700 to 6,19,622. These are the distribution. Okay, since minus values are there, so it is a matter of concern for us. We need to censor it. Okay. So how we could able to censor it in the data? So let us open the data first, then we can able to discuss. Okay. So first of all, okay. So just a minute. So all right. So now we are going to open the data that is Tobit practice. Okay. Now this has already been opened. We are going to do something very quickly, that since GB has already been defined, we need to compare GPA1 with the value if GPA has less than 0 or negative values. Okay. Now, let us redefine the GPA with a new variable called GPA1 if that is having GPA less than 0. Okay. All right. So, it is here. So, we are defining a value here, then this. So, GPA1 already okay, we have already defined. So, we can drop that variable at this moment, it is there. All right. So, now once again we are going to run the same command. So, GPA1 is defined now, GPA1 is here, it is visible at the end. Okay, GPA1. And now we need to replace the GPA1 okay, is equal to 0. We want to censor it with a 0 value if it is less than GPA1 is less than 0. Okay. So, now very quickly we have now get 8 real changes, that means 8 cases where the values are negative. Okay. Now that those have been converted to 0, isn't it. So, let us move on, and we wanted to find some other interesting interpretation. Now, keep in mind that our dependent variable, that is GPA, is not dichotomous but continuous in nature. Okay. So, so that is basically 0 and above. All right. So, that is interesting to note, but usually in Logit and Probit it has to be mandatorily dichotomous. So, our variable of interest here is asset value that is continuous, okay, also location, and any other interesting variable you wanted to include, you can include. So, we are going to test with this this one as the dependent variable was GPA1 right now. So, we will simply run a simply go by a ordinary least square method, since it is a continuous variable. So, let us compare, okay, how Tobit and these two can be compared. Okay. So, this is our ordinary regression coefficient, okay, that has been defined with respect to asset value, location of the enterprises. All right. Now, let us go to the explanation of through Tobit. Okay. So, we are going to define through Tobit now. We have defined already for ordinary least square. So, let us define it through Tobit. Okay. So, Tobit is going to give a little different result, and that is interesting to note. And here the Tobit, our command is here for at the end we have a lower limit. Okay. Lower limit in general we have written, on specific lower limit we can also mention. Okay. So, when we have defined this at the end LL not 11, please read, this is an LL lower limit. In general the lower limit we have defined. Now, this is the Tobit result and this is the OLS result. Okay. So, now what we will do, we will discuss here. We have used already a censored variable, that is GPA1. Okay. GPA1 is a censored variable. Now, using the uncensored variable GPA, we can go by the GPA also, okay, like this. So, GPA uncensored variable. So, how it looks like, we can compare. Okay. Now, GPA is our uncensored variable. Okay. So, now in this model it is not GPA1, this is only GPA, where the negative values are also included. Okay. Now, what is interesting to note here is that please mark it here we are mentioning in the command as lower limit. Okay. If you have any upper limit also, you can write down with at the end UL as the upper limit. If both are there, lower limit and upper limit with the particular value. Okay. Here we are considering 0 as our lower limit, because below that we have already censored. So, upper limit, if you have a particular value, maybe 66,000, okay, or maybe 50,000 above, we are not going to discuss. Okay, that limit you can set. As you can see in both the models that there is a little variation in the coefficients values of OLS and Tobit. Okay. Now, Tobit regression coefficients are interpreted in the same manner as the OLS coefficient. For a 1 unit increase in the asset value, there is 8%. 0.008% increase in the predictor value of GPA. Okay. So, now here it is the case with the asset value case. So, 0.00777, so roughly 0.008, all right. So, that is the interpretation. Now coming to this, we wanted to say that okay, not a problem, we are just finalizing. For a 1 unit increase in the asset value, it is of 0.008 point increase in the predicted value of GPA. The marginal effects are just the same as from the regression model. Okay. So, basically all other tests you can do it the way we have already done it. Okay. So, rest of the detail you can experiment and find out. If you have difficulties, please come up with the doubts, we will be very happy to explain you in detail. So, all the qualitative dependent variable models or the dummy variables models have already been completed. So, this is all for today in this lecture. From the next week onwards, we are going to unfold the discussion of panel regression using Stata. Okay. So, thank you very much.